I can start the demonstration, right?
Yes, please. You are co-host, so you can share your presentation.
Okay. Uh, can you see the slide, the first slide of my presentation?
Yes.
Okay. So, hello. My name is Denis Avariaskin, and I'm an associate professor of Space Research Department of Samara University, which is in Russia. So, Samara is not very far from Moscow. It's about 1,000 kilometers. Um, And here in Samara University, we try to teach our students space technologies uh, through the research. Um, so today I'm going to tell you about how do we implement this approach for education in our university. So first of all, I want to start with um, space technologies. So uh, basically, space technologies, they are based on spacecrafts or satellites, which fly around the Earth, or they can go to other planets. And when the space exploration started, it was in 1957. Uh, the satellites, were divided only into three types. They were large, medium, and small satellites. Uh, and at that time, small satellites, they had mass from 100 to 500 kilograms. Um, that kind of satellites was small. But since that time, the technologies, they go further, and the electronics, it becomes smaller. So after that, the satellites also become smaller. And when uh, people start to build satellites from 10 kilograms to 100 kilograms, they started to think, how do we call them? Because small satellites we already have. And they start to call them microsatellites. But the progress didn't stop, and satellites become even smaller. Um, and people start to think how to call the satellites which is smaller than micro, and now we have nanosatellites. So nanosatellites, basically, they are spacecraft which have mass from 1 to 10 kilograms. Now we have even smaller satellites, which is picosatellites. It's more than 100 grams, but they are not so popular as nanosatellites. So in our university, in Samara University, in Space Research Department, we try to teach our students using real spacecrafts, real satellites. Um, we use nanosatellites. So the advantage of this kind of spacecraft is that it's quite small and not as expensive as a big ones, the large ones. Of course, comparing to the large ones, they are not expensive, but still, nanosatellites, they are still spacecrafts, so they are quite expensive comparing to technologies that we have here on Earth. Um, so that's why we choose this kind of satellite to use as an object which we can create here in the university, and our students, they have an opportunity to join the projects of real satellites that we launch to space. And Now, here in this slide, I want to show you the difference between nanosatellites and large spacecraft. Basically, the difference is the same as the difference between little cats and polar bears. So both of them, they can do the same things, but the difference between them, it is only in power and in dimensions. Of course, cats and as well as non-satellites, they are smaller than polar bears and large spacecrafts. But inside, they consist of the same onboard systems, and they can do the same, but not so powerful as big ones. So that's why students that can figure out how to work with nanosatellites in future, after when they graduate the university, they can work in big companies that create satellites, the big ones, and they already have an experience in real space technologies because they have trained on small ones. That's why I think that it is an advantage to use these kinds of satellites. One more difference, one more advantage of small satellites we can see on the next slides. So here I want to give you an example. So if, for example, if we want to have photographs of or pictures of our Earth, so we can take a large camera like here on this slide. You can see here. We can take a large camera. We can build a uh, large satellites. We can launch it, and it will fly around the Earth and will take pictures of quite small area on the ground on the Earth. But the pictures will be very detailed. It will have a good resolution. So pictures will have a very good quality. So we can even read a paper of a person in a park, for example, um, from the orbit. But we can take cameras which smaller, and we can launch a lot of small satellites, for example, nanosatellites, and we can have pictures of our Earth, of larger area of our Earth. Um, of course, the pictures, they will be not, they will have not the same quality. It will have not so good resolution, but still we can solve some problems. For example, we can watch and predict the fires in forests. We can investigate the movement of clouds to predict the weather, make weather broadcasts. And this we can solve with small satellites, but we can use a lot of them. So this is an advantage, one more advantage of small satellites. So what kinds of tasks or what kinds of problems we can solve with nanosatellites more. So here, one more example. So we can launch nanosatellites as technology demonstration. So for example, we can test new technologies, new structural elements, or already existing subsystems, onboard subsystems. We can test the new onboard subsystems or sensors. We can test the technology of formation flights, so it's flight of group of satellites. Also, we can test some kinds of communication. So before we launch a big satellites with a new technology, we can test it on a small one, which is cheaper. So we can spend not a lot of money if something goes wrong with the new technology in space, because the space is quite aggressive environment to our devices, and that's why it's cheaper to test new technologies using small satellites before we going to start to use them in big projects. So here some examples of technology demonstration nanosatellites. On the left side of the slide, you can see the German spacecraft, German nanosatellites TUBSAT N and TUBSAT N1. And you can see that they were launched 35 years ago, so it was 1998. These two spacecrafts, they had mass 8.5 kilograms and 3 kilograms. So basically, both of them, they were nanosatellites, and they were launched a very long time ago. So nanosatellites, they become popular quite a long time ago. So from the right, we can see one more example, MEPC 1A satellite from USA. It was launched at the same year, so very long. It's also two satellites for demonstration of technology of formation flying of inspection. So one satellite should inspect the other one. So these are examples of technology demonstration. Also, we can use nanosatellites for Earth remote sensing. Earth remote sensing, basically, this is watching the Earth surface from the orbit. We can use it in different purposes for agriculture, forestry, hunting, or we can make maps, so it's cartography. We can use this information for geology or geodesy, oceanography, meteorology, and so on. So pictures of our Earth from the orbit, they are very useful. And we can get the pictures not only in optical frequencies, but in other frequencies as well as infrared or ultraviolet to get different information about our planet. So here are a couple examples of satellites that used for Earth remote sensing. The first one was a group of 28 CubeSats. CubeSat, this is the kind of spacecraft, the most popular kind of nanosatellites. So CubeSat, this is basically a satellite which has the shape of cube. Each side of the cube has dimension 10 centimeters or 100 millimeters. So one cube is the cube with the side of 100 millimeter, and we can combine different cubes, 1, 2, 3, and more to make satellites. And the next example of nanosatellites, it was not CubeSat, but it's still nanosatellite. So it was PRISM, the Japanese nanosatellite. Okay, so also nanosatellites can be used for the automatic identification systems. So basically, this is the system to avoid collision between the vessels in the ocean or in the sea, in the different seas, in different oceans. So they control the motion of these vessels, the traffic of it. So we can use these sensors that receive signals from ships, and we can control the traffic of ships. And here are some examples of nanosatellites that was used for these kinds of purposes. This was Canadian and the satellite from Norway. Okay, so the next kinds of mission that can be used for that nanosatellites can implement, these are communications. So nanosatellites can solve problems, some problems with communication. So here you can see two examples of space missions with nanosatellites. So the first one is TNS-0. It was a Russian satellite that worked with a Global Star satellite system. Global Star, it is a satellite system. These Global Star, they are not non-satellites, they are large satellites, and they are communication satellites, so they provide a satellite communication from the ground. And the next example is SMDC-11. These satellites of USA, also it was basically military satellite for communication for military purposes. Also, we can use nanosatellites for different scientific to solve the different scientific problems. Here, an example, we can use small satellites to predict earthquakes, for weather broadcasting, meteorology, and for different scientific experiments. So these quite wide problems that we can solve using these satellites. Here also two examples of satellites that solve these problems. The first one, AirAX satellites from USA. It was launched in 2010. So this satellite was investigating atmosphere and ionosphere and ionospheric plasma. So the next satellite, Indian satellite, SRMSat. It was mission that to monitor the greenhouse gas. So basically it's measured the carbon dioxide in atmosphere. So to control the climate of our planet. And the next scientific tasks that we can solve, we can measure magnetic field of our Earth. So I hope you know that our Earth surrounded with magnetic field that protects us from the solar wind, and we can measure this magnetic field to know how it works and how we are protected from different rays that fly not only from the sun, but also some different cosmic rays that are not very good for a human body. That's why we should be protected from them. And here also two examples of satellites that measure the magnetic field of our Earth. Here also, even these small satellites, that nanosatellites, they can be used for biological experiments. And of course, we cannot put a human inside this small box. of nanosatellite, but some bacteria, some micro bodies we can put inside a satellite, such as nanosatellite. So here two examples of satellites with bacteria that was launched um, more than 20 years ago. Also, we can use a solar sail um, to uh, to make less debris of spacecraft in the orbit. So here are some examples of solar sails that help us um, to re-entry a satellite from the orbit to the Earth. So when the satellite stops working, uh, it fly around the Earth, and when it doesn't work, so we need to get rid of it um, because it's become a space debris. So that's why we can re-entry our satellites using these solar sails. So here are some examples that tests this technology. Also, we can use nanosatellites to study space debris. So the first example here of nanosatellite that study that um, can monitor this space debris. It was American satellite, and the next one it had a it had a good reflection to test the technology of monitoring space debris from the ground. So we can see this satellite like with not very powerful optics in space because it has a very good reflection. So what do you have to know to create a nanosatellite? So here, before I wanted to give you like a lot of information about why do we need such small spacecraft, why they can be useful for us, how they can be useful for us. And now I'm going to tell you what do we teach our students to create these kinds of satellites. And all this knowledge, it's applicable for every satellite you want to create. So first of all, we teach students the mechanical design. Basically, we tell students how to make a structure of satellite, how to install inside of this structure all the onboard subsystems, how to make it like in more optimal way. So the next, it's electronics. Of course, each satellite, it is first of all an electronic system. It consists of PCBs. So inside, so it's electronic device, and we teach students how to work with electronics and how to test it. Because we cannot create a satellite without it. Of course, programming. So we need students or all the people who work with satellites. We need to make a code that work in our satellite, and also we need to make software to work with satellites. So we should have on our computers, we should have a software to work with satellite and we need to create it somehow. That's why we need a programming. So also we teach programming our students. The next thing is ballistics. So the motion, ballistics is basically the motion around the Earth, um, the motion in orbit. Um, we need to calculate how our satellite will fly, where it will fly, because um, we need to predict the communication sessions. So when the satellite will fly above our ground station, so we can have a communication with it from the ground. And all of these tasks we can solve with ballistics. Uh, the next thing is management. So we should plan our work on a satellite. So what tasks should be made first? What tasks should made later? In which order we should choose? So this is basically the management. So this is also an important part of creation of a satellite. The next thing is thermal analysis. So basically, when a satellite flies around the Earth, um, one period around the Earth, so one turn, the satellite make approximately for 1.5 hours. So 90 minutes. During this 1.5 hour, the satellite the temperature in the satellite rises in the part where sun hit our satellite, and in the eclipse, in the dark side, so when the satellite fly in shadow of our Earth, the temperature goes down. And during this 1.5 hour, the temperature can go up and then goes down, up and down. And this is not very good for structure or for electronic systems, so that we need to make a thermal analysis to estimate if our subsystems will work in these conditions. So the next thing is strength analysis. So we have to be sure that our satellite will survive the flight inside the rocket, because the rockets, it's all the rockets that take our satellites to the orbit around the Earth. They have very powerful engines, and when these engines work, um, the vibration is very strong. So our satellite should survive these vibrations. So its structure should have a very good strength to survive the flight in the rocket. That's why we need to calculate it first. The next step is manufacturing. So we teach our students how to produce the onboard subsystems. So here you can see the photographs from our laboratories and the photograph of one of our satellites. Uh, More about our satellites I'll tell you a little bit later, that we have made. So students, when they graduate, they have to know how people produce all the onboard subsystems, and that's why we teach the manufacturing uh, of spacecraft. Also, the important part of creation of any spacecraft is testing, because when the satellite flies around the Earth, and if something goes wrong, it's quite difficult to go to the orbit and fix the problem if a satellite has one. So that's why before the launch our satellites in the orbit, um, we need to test it. We need to make all the kinds of tests to be sure that our satellite will work in orbit. That's why it is a very important part. Um, we have in our department in Samara University, we have a testing center. So also I will tell a couple words about this testing center. And here you can see the pictures from our testing center. And the next step is launch. So when we made all the calculations, when we create a satellite, when we produce all the onboard subsystems, we assemble it, then we made all the tests. The next step is launch. So we teach our students how the satellite can be launched in the orbit. And after that, when satellite already in the orbit, the next step is operation. So we teach our students how to work with satellites when it's already in the orbit. How can we receive information to the ground station? How can we process all the data that we get from the satellite? So how can we solve the problem that we want to solve with our satellite? So this is the operation. So this is it, what a good specialist has to know when he when he want to work with a satellites. So here you can see like a table with the um, all the with the team that you need to have to make a satellite. Of course, this is an ideal one, and here all the kinds of work that we need to do, and um, usually nanosatellites created by very small teams and different tasks that you can see here in colored boxes. So they can be made by one person. Uh, some of them um, can be made by one person. So, but in ideal world, of course, each um, task should solve with a special person who can make it very good. Um, so how you can learn all of this that I have told at Space Research Department of Samara University. So what do we have in our university to create nanosatellites? Um, so first of all, we have two educational programs. Bachelor program, it's 4 years, but it's only in Russian language. And it's called Small Spacecrafts and Nanosatellites. And also we have a master program for 2 years. It's called Advanced Space Technologies and Experiments in Space. It can be in Russian or in English. The cost of education you can see here, but it's the cost of this year. In the next year, it can change a little bit. So approximately, if you want to calculate it in dollars, $1 it's 90 rubles for now. But of course, here in Russia, it can change like very fast. But foreign students can join our university with Россотрудничество quotas, like to get a scholarship to study in our university. So if you will be interested in, so at the end I will give you my contacts, so you can ask me how to join this program, and I'll give you the contacts of our international department that will tell you what to do to join the bachelor or master program. But if and here you can see the subjects that we teach our students. So I divided them into categories. It's of course it is better to have a better knowledge, better understanding and better skills in space technologies, you should have a bachelor and master degree in these space technologies. And the categories that we have here, what do we teach our students? It's engineering, of course, it's electronics, navigation and control, so motion, it's ballistics basically, science, so it's why do we need to launch satellites, and what scientific tasks we can solve with it. So here, like theoretical part of education, and here we have a practical part, like application of the theoretical knowledge that you get in first part. So here we have internships. Um, the when you get a bachelor degree, you have three internships. The first one is IT and space technology. You students they study how to program the satellites. The next one is testing technologies. So our students go to our nanosatellite testing center. And the third internship is manufacturing. So we try to send our students to different aerospace organizations. But here in Russia, with this part, quite problems because usually the organizations, the state organizations, aerospace organizations, they cannot teach foreign students. So we usually teach our students in our university for manufacturing. And in master, when our students get master degree, we trying to send them to space science organizations of Russian Academy of Science. And students during the study can join the projects of our satellites. Of the bachelor students of first 2 years, we can involve into projects of CANSATs. So this is a very small satellites, like about half a kilogram. And on the third or fourth year students, we can involve to the projects of CubeSats, of simple CubeSats. And master students, we try to involve in scientific CubeSats that we create in our department. So if you already have a bachelor or master degree and you want to have an additional education, we have 9 month trainings. The first one is advanced space technologies and experiments in space. The second one is GNSS receivers, hardware and software. So as I told before, this is 9 months. It's the amount of hours, it's equal to 1 year of bachelor or master degree. So in European system, it's 60 ETCS. And the cost of study is 300,000 rubles per person. And we start the program if we have 8 or 10 people in the group, so we can start this program. So this for those who already have a higher education, I mean, who already have a bachelor or master degree. Also, we have a short trainings, so 1 week, 2 weeks, and for 1 month. The cost here is for the program, not for a person, but for a program. So in the group, there can be up to 10 people. So you can divide this cost to the number of people. So if you have a group of 10 people, you want to have the short educational program, for example, for 2 weeks. So you divide 180,000 rubles divided by 10. So, and the courses can be in English or in Russian as you wish. So what facilities do we have for studying? Of course, we have the laboratories where we produce our onboard subsystems and the structures for our satellites. We have a training models of satellites, engineering model. So here at the bottom of this slide, you can see the examples. So uh, also, as I told before, we have a testing center. So you can see the equipment that we have in our testing center. First of all, we have thermal vacuum chamber to test our satellites for the influence of space environment. So it's vacuum and different temperatures. Vibrodynamic stands to test the strength of structure of our satellites and other different devices. Also, we have a ground station to control our satellites, to receive data from our satellites, and to send commands there. It's also in our department. So all the students, they have classes in these laboratories and this ground station. And here, the satellites that we have already made. The first one is SAMSAT 218D. SAMSAT stands for Samara satellites. So all our nanosatellites, they call SAMSAT, like Samara satellite. The first one, it was launched in 2016, 8 years ago. The second one is the part of international project QB50. Unfortunately, we made the satellite. And we have tested it, but unfortunately, we haven't launched it in the orbit. And the last one is SAMSAT Ion. This is the satellite. This satellite was launched this summer in this year in the orbit. So now it is the orbiting our Earth, and it was for to study ionosphere. SAMSAT QB50 was for to study atmosphere of our Earth, and the first satellite 218 it was for to test our onboard subsystems. So we want to be sure that our first satellite was very simple because we want to be sure that all the onboard subsystems that we made they work. So this is it for my presentation. Thank you very much for your attention. Here you can see the contacts that you can use to contact me anytime you want. Thank you very much. If you have any questions, I'm ready to answer.
Yes, thank you very much. Now this is a space for questions. I don't know if someone have any questions for the Professor Denis. Please. Well, there we have some comments by Hannah. Thank you. It was really interesting.
You're welcome.
Thank you, Hannah. Well, if there is no more questions, I only have to say thank you,
Thank you.
to you. That was for all today. See you in another time. Thank you very much.
Okay, thank you. Bye bye.
Goodbye. Los invitamos a que se puedan conectar a la conferencia de más tarde, que será pronto, y pues a seguir con la programación de estos últimos días que nos quedan. Muchas gracias, hasta pronto.